Now let us talk about the domain and range of these inverse trigonometric functions. So I hope you all remember, let's say for trigonometric function, let me take an example. For sine x, what used to be our range? Our range used to be from -1 to 1. And what used to be our domain? Our domain used to be all real numbers, right? Now for inverse trigonometric function, what happens is our range would simply become our domain. This is sine inverse x. However, our range would not be all real numbers. It would not be the domain of our normal function. Our range would be from -pi/2 to pi/2. So as we had seen earlier in the graphical representation, the graph of sine inverse x is only up till here. I mean, it does not continue further from 1 and it does not go further from -1 as well. So it is just one line and just a one curve between -1 and 1. So this is how the range is written down. For cos inverse x, again the same thing. However, since cos inverse x is above the x-axis, that is why its range would be from 0 to pi. For tan inverse x, now we can apply our domain to be complete all real numbers, because for tan inverse x, what was the graph that we had studied? This used to be our graph for tan inverse x, right? So you can see that in our domain, all values of x are considered. However, in our range, it is only from -pi/2 to pi/2, and where we do not include our -pi/2 and pi/2 exactly, because at that values we have infinity as our answer. For cot inverse x, again r and 0 to pi. Simply cot inverse x, what happens is it shifts above the x-axis. For sec inverse x, now again it is all real numbers. However, it is not defined between -1 and 1. So that is why when we write down the range as well, we would get 0 to pi. However, pi/2 would not be included. If we look at the graph once again, for sec inverse x, you can see that from -1 to 1, the graph is not defined. So, and at pi/2, since from both the sides, both the curves are approaching to pi/2, either I approach pi/2 from here, or if I approach it from here, it is going to be infinity, right? What does it mean? It is not defined at pi/2. That is why we remove pi/2 from its range. Similarly, for cosec inverse x, we remove 0, because you can see at 0 our graph basically approaches infinity and minus infinity, so it cannot be defined at that value as well. So this is how basically the domain and range varies of inverse trigonometric function with the trigonometric function. Now let us look at a few properties. These are again properties whose conditions is the most important thing that you must remember, because I hope you all remember in trigonometry we had studied and we had looked up at questions where they used to give us a very long trigonometric equation, and they used to ask us what would be the number of real solutions, or what would be the number of solutions for this entire function, right? So similarly to in inverse trigonometric functions, you would also be asked questions in that form only. However, now you would have to remember the range as well. So up to where the property or the composition would lie up to. So for example, if I have sine inverse sine theta, output would be theta, of course, because let's say if I say my sine inverse sine theta is, let's say, my y, and I have to find out my value of y. So from here what I can say is my sine theta would be equal to sine y. And if this is the case, simply I can say that my theta should be equal to my y if it lies in this range. Now, if it had been, let's say, apart from this range, what would happen? I would have to add either a pi minus or a pi plus in my output. I hope you are understanding this thing. Let's say if I had sine inverse sine, let's say pi. So this answer would not simply be just pi, because what would happen is if I write, let's say this is my y and I have to find out what my y is. So I can say my sine pi would be equal to sine y. Now my sine pi, this value is going to be -1. However, when I look at sine y, what is the values that are possible here? It can either be, sorry, sine pi is actually 1. So what are the values that are possible? It is going to be n pi, right? So that means there are a lot of values that are possible. That is why we are putting this condition that it must lie within this range. inside our sine inverse, if we have sine theta or trigonometric functions, then our output is simply going to be theta based on some conditions, right? Now, what if instead of trigonometric function, we have inverse trigonometric functions inside? Our output is still going to be the same. It is going to be x for all the values. Instead of the only thing that changes here is our condition. So earlier we had the condition of theta. Now we would have the condition of x. Now let's say if our x lies from -1 to 1, then we would have x for sine of sine inverse x. Now let's say if our value becomes something which is not in this range, then of course we would have to first find out which quadrant it lies in, and then based on that we need to make our informed decision whether our output is going to be pi minus x, pi plus x, minus x or plus x or whatever. So based on the range, we are supposed to find out our output for such type of functions. So keep this thing in mind. Now, talking about, let's say if we have sine inverse of minus x, so it would basically become minus sine inverse x. Again, these are few properties that you must remember. Now, I'll just show you the proof of any one of these properties. Based on that, you can solve the proof of other properties as well. I'll show you how cos inverse of minus x becomes pi of minus cos inverse x. Based on this, the same method of proof you can apply to all other different inverse trigonometric functions and find out your proofs or properties, whatever you are getting. So let me assume that my theta is equals to cos inverse of minus x. And basically I need to find out this theta in some other terms, right? So first of all, I can see that this would become cos of theta is equals to minus x. So from here I would have minus cos theta is equals to x basically. So from here, when do I get minus of cos theta? When it is going to lie in my second quadrant, right? So in my second quadrant, I would get cos theta as negative. So basically I can write this down as cos of pi minus theta is equals to x. So from here, what do I get? Pi minus theta is equals to cos inverse of x. From here, I get my theta as pi minus cos inverse x. So I hope you've understood this. Now, simply if I replace my theta with cos inverse of minus x, so this would become cos inverse minus x is equals to pi minus cos inverse x. So this is how we've gotten this. So this was the proof of any one of this. Of course, in your examination, whenever you've given question of inverse trigonometric function, you can always assume that trigonometric function to be some other variable, let's say a, b, theta or y, and then try to solve it using your normal trigonometry. Or the better way is that you remember such properties and write down your answer directly. So I think remembering the properties is much easier so that you can solve the questions quickly during your examination. So here are a few more identities. Let's say if you have sine inverse x plus cos inverse x, it would simply become pi by 2. So how can you prove such type of questions is that you can assume sine inverse x to be A, cos inverse x to be B. Now you would have basically x is equals to sine A and x is equals to cos B. Based on that, you can simply use your addition formulas or subtraction formulas, and based on that, you can get this answer. So of course, proof is very easy for all these. You can prove them by yourself. And in fact, it is recommended that you remember such identities so that it becomes easier for you to solve and convert questions into same type of trigonometric functions. Second identity is, let's say you have tan inverse x plus cot inverse x, it would become pi by 2. Sec inverse x plus cosec inverse x, it would become pi by 2. Now, keep this thing in mind that for all these three identities, there is a certain condition for x which needs to be satisfied at the time of the question. Let's say if this condition is not satisfied, then your answer would be something different. It is not simply going to be pi by 2. So keep the conditions as well, the domain of x as well in mind while solving such questions. Now let's say if you have finding out the sum of any two inverse trigonometric functions, let's say you have tangent. So of course its formula is going to be in this format. You must remember this. Tan inverse x plus tan inverse y gives us tan inverse of x plus y upon 1 minus xy. Now, in this type of sum, there is a condition given that xy should be less than 1. Now, why is this condition given? So that we can find that 1 minus xy is always positive. If my xy is less than 1, then 1 minus xy would always be positive. Had it been greater than 1, then I would have gotten my value to be negative, right? Then my answer would have changed completely. Then I would have to plot in which quadrant my theta is lying in, and based on that, I would have to give my answer. However, if I directly need to write down the answer, I must find out for this condition as well. So let's say if my xy is greater than 1, then it would become pi plus tan inverse x plus y upon 1 minus xy. Keep this in mind as well. If I have tan inverse x minus tan inverse y, so this would become tan inverse of x minus y upon 1 plus xy. So keep these formula in mind. Do not forget the conditions, and based on which condition you are having pi plus or pi minus and all these things, you have to remember such identities. Now, double of any tan inverse tangent, of course. Here, basically, we are going to use the same formula of inverse tangent that we studied here. So, basically, what I'm doing is tan inverse x, I'm doing tan inverse x, I'm adding it twice. So, basically, this would use this formula only, tan inverse x plus y upon 1 minus xy. So, I would get tan inverse x plus y. So here I have x plus x, it would become 2x, and I would have 1 minus xy. Y is also x here, so it would become 1 minus x squared. So of course, basically I'm using this formulas only to find out my double of inverse tangent. Keep this in mind. Apart from that, now let's say sometimes whenever questions of inverse trigonometric functions have been given to you, it is recommended that you first convert all the functions that have been given to you in the question in the same trigonometric function. Let's say if you have in the sine format, try to convert everything in sine. If you have in tan, convert everything in tan, and then try to solve your question. Such ways, it would become very easy for you to solve the question. So similarly, you must remember a few conversion formulas as well. So let's say if you have 2 tan inverse x, it can be written in sine inverse format as sine inverse 2x upon 1 plus x square. To tan inverse x, it can be written in terms of cos inverse as 1 minus x square upon 1 plus x square. Now again, you must remember this conversion because it can come handy while solving questions. Now sum and difference of, let's say, inverse sine or inverse trigonometric function. So for tan we studied. Now for sine, let's say if we have sine inverse x plus sine inverse y is equals to sine inverse, this is what we are going to get. Now let's say if in your examination you forget, of course it is a very large formula for you to remember, right? So if you forget, I'll show you the proof how you can solve it. Based on that, you can also find out your answer. So what I'll do is, I'll assume my sine inverse x to be A. I'll assume my sine inverse y to be B. As I had told you initially, to solve any questions of inverse trigonometric functions, you can simply assume them to be some other variable, and then based on that variable you can use either sum identities, difference or quotient identities and all those things. So first, since I've assumed this, that means what can I say is that my sine A is basically x and my sine B is basically y. Now what I'll do is I'll try to find out that sum sine of A plus B. What is it going to be? Sine A cos B plus cos A sine B. This is what I'm going to get, right? Now, since I know that sine of A plus B, here sine A would simply be x into cos B. I would have y into cos A. Now I need to find out the value of cos A and cos B. Now I know that my sine A is equals to x by 1, which is nothing but my perpendicular by hypotenuse. If I consider this to be a triangle, basically I would have x by 1, which is perpendicular by hypotenuse. So from here, what would my base become? Base would simply become 1 minus x square, right? So basically my cos A would become base by hypotenuse, which is 1 minus x square by 1, base by hypotenuse. So this is how I get my cos A. Similarly, if I need to find out my cos B, what would my cos B become? Since my sin B is y, so my cos B would become root under 1 minus y square. Now if I replace these values, what am I going to get? Sine of A plus B, this would basically be equal to x cos B. So x into root under 1 minus y square plus y into root under 1 minus x square. Now, since I had sine of A plus B, what I'll do is I'll take sine as inverse to the other side. So this would become sine inverse of x root under 1 minus y square plus y times of root under 1 minus x square. So from here, now if I simply replace my a and b, what was my a? My a was sine inverse x, my b was sine inverse y. So sine inverse x plus sine inverse y would give us this answer. So of course, you can use such formulas to prove these inverse trigonometric properties. But again, as I mentioned, it is recommended that you remember all these properties. Similarly, let's say if you're in your condition, you have x square plus y square greater than equal to 1, then your answer would become pi minus sine inverse of the same thing. Let's say if you have minus, then instead of plus in the between, you would simply have a minus sign. So keep the conditions in mind as well. Similarly, for cos, of course, for cos, sum and difference is also going to be almost the same thing. You can use again the same tricks that we used here to prove sine. You can assume your cos inverse x to be a, your cos inverse y to be b, and then based on that, you can find out your cos inverse x plus cos inverse y. Few more properties that you must remember, of course, sine inverse 1 by x can be written as cos inverse x. Cos inverse 1 by x can be written as sec inverse x. Tan inverse 1 by x can be written as cot inverse x, provided that x is greater than 0. And it can be written as minus pi plus cot inverse x, provided that x is less than 0. So keep this thing in mind. It is not pi minus cot inverse x, it is minus pi plus cot inverse x. So do not confuse yourself with the sign. These are important results that you must remember by heart. Now, let me give you one more important property of conversion of any trigonometric function whenever you have, let's say, asked the question in a triangle format. Let's say this is my triangle. I have my theta here. Let's say this is my theta, and I'm considering that the perpendicular, basically if this is my theta, of course this is going to be my perpendicular, right? And this is going to be my base. So if my perpendicular is x, my hypotenuse is 1, what would my base become? Root under 1 minus x square, right? Had, let's say, this would be my theta, then this would have become my perpendicular and this would have become my base. However, again, it depends on where you are taking the theta. So keep this thing in mind. Let's say I'm assuming my triangle to be in this format. So from here, let's say if I have theta is equals to sine inverse x. So basically I'm saying that sine theta would be equal to x by 1, which is nothing but perpendicular by hypotenuse. This is my hypotenuse, right? So basically my theta is equals to sine inverse of perpendicular by hypotenuse. Now based on this, you can convert it to any trigonometric function you have. So you can write down your theta as sine inverse p by h. Similarly, you can write down your theta as cos inverse of b by h. Similarly, you can write down your theta as tan inverse of p by p, because tan inverse is perpendicular by base. So from here you would get this as x by 1. Sorry, this would become sine inverse of x by 1. Sine inverse of x by 1. Your cos inverse x, this would become cos inverse of root under 1 minus x square by 1. And your tan inverse, this would become tan inverse of x upon root under 1 minus x square. So what I mean to say is that sine inverse x is basically equal to cos inverse of root under 1 minus x square, and that thing is equal to tan inverse of x upon 1 minus x square. So all these three are equal. So definitely, whenever you have been given any type of question, you can use these conversion formulas to convert your trigonometric functions into one simple trigonometric function and then solve your question. Apart from this, sometimes you might have to use these conditions as well. Let's say if you have tan 2 times of tan inverse x, you can write it down as sine inverse of 2x upon 1 plus x square. If you have 2 tan inverse x, you can write it down as cos inverse x 1 minus x square upon 1 plus x square. So keep these conversion techniques in mind, can come a lot handy while solving questions. Now, majorly the theory part is complete of this chapter. This is just one more formula that you can remember. Let's say if instead of tan inverse x plus tan inverse y, you have three different functions added together. So what would it become? It would simply become tan inverse of x plus y plus z minus xyz upon 1 minus xy plus yz plus zx. Now, of course, you must keep in mind that since I have 1 minus some term, right? So this term basically should be less than 1. So that is exactly the condition that we have given here, that this value should be less than 1 to ensure that the denominator is always positive. Had, let's say, my denominator become negative, then of course what would it become? It would become pi plus tan inverse x, or pi minus tan inverse x, as per the formula we had studied before. So here also we had studied, let's say if my xy is greater than 1, then it would become pi plus tan inverse x. Similarly, here I would have pi plus tan inverse x if this condition is not satisfied. So keep this thing in mind.